Okay, yes. So I see, okay, Miss Pratt, Fernanda, Nairn, and La Rochelle. Okay, so today we're going to move on to another section of your text dealing with sets. We are moving on to look at sections 2. Let me see what I did here. Give me a moment. Okay. I'm gonna share your screen. Start now. Right here. Okay. I guess you all should be able to see my screen now. So we're moving on to look at sections 2.3 and 2.4 of your textbook. But before we get into that, which will go a little more detail on the videos that the short video that we saw just now, I note that I only received homework from 2 persons, Miss Fernanda and Miss Pratt. I asked that you take a photo of the homework and send it to me so I could credit you for doing it. So Miss, let me see, Miss Nairn and Miss La Rochelle, did you do the homework?
Yeah, I sent the email on Sunday asking you how you wanted me to send it, and I never got a response.
Oh, okay. I needed to take a picture of it.
Okay.
Email it to me. And also I sent you an email for a phone contact because when we need to make immediate contact, I don't have a phone. So if you could put that in your email, Mr. Rochelle, because I don't have a phone contact for you on the register.
Okay, I didn't get that email. I'm not sure why.
Oh, okay. Ms. Nairn, did you do the homework?
Yes, I did. I emailed it to you this morning, right before the class started.
Okay, all right. So I'll look at it later then. All right. Now, I think it was Miss Fernanda. Miss Fernanda, you there?
I'm here, yes.
Yeah, the homework, what I have done, let me see if I could go to is the question numbers on on maybe 2 of the slides. So you're going to look at the question numbers at the top, and then I have the questions attached. Some of the questions may take a few pages, maybe 2 or 3. And so you're only to do the question numbers that are listed. Okay, so when we get to the slide for this class, I'll explain it again. Because we had to cut short last time, I didn't get to explain it fully. So just the numbers that are listed you are to do. I think it's mostly odd numbered questions, and it's not all of the odd numbered questions. So just the ones that are listed. Okay, now if you have the book, you could refer to the book, but if you don't have the book, then I have the questions copied onto the slide. So you could just use that to assist you with knowing which questions to do for homework. All right. So the homework, were there any issues with any of the questions anybody wanted to bring to our attention before we start with this class? Because the answers are there. So I'm not going to be checking the homework. All I want to see is that you did it. Once you do it, you get credit. Remember, homework contributes towards your overall final grade. So if you don't do it, that's, I think it's about 10. How many points I have here for homework? Let me check. Homework. Yes, 10%. That 10% could make a big difference. So make sure you do all the homework. And once you do it and you take a picture and show it to me that you did it, then you'll get credit for it. If you do all 14 of them, then that's 10% automatically you get towards your overall grade. Now, like I said, the answers are there, so you could always check your answers. And if you don't understand how an answer was arrived at, then this is the time now when you can ask the question so we could discuss it.
Okay, Mr. Allen, morning, everyone.
Mhm.
I wasn't sure about question number 77 and number 49.
Okay, 77 and 49. Okay.
49 would be one of the last questions for homework.
Okay, so let me see if I can find those. Section 2. All right, so 77, that's the one that says x such that x is a natural number and x is greater than or equal to 2 and less than 7.
Yes.
Okay, so it must be greater than 2, or sorry, greater than or equal to 2. So it's going to be 2, 3, 4, 5, 6. And it has to be less than 7.
Okay, I didn't take the symbol you saying less than 2 or equal to. I was just looking at the symbol that had to be equal to 2.
No, it's
And less
greater
than
than or
7.
it's greater than or equal to 2. So remember now, when x is in the middle, you're gonna have to read it in the reverse because it says 2 is less than or equal to x. But when you read that, it's going to be x is greater than or equal to 2 when you reverse it. So the number has to be greater than or equal to 2 and less than 7. So greater than or equal to 2, that means it can be equal to 2 and it could also be greater than 2. So you're going to start with 2, 3, 4, 5, 6, and you will not include 7 because it said it has to be less than 7. So anywhere between 2 and 7 for that.
So the answer sheet gave us 5. Why didn't we put 2, 3, 4, 5, 6?
Say that again?
The answer sheet gave 5.
Okay, let me see the answer sheet. I have to look for that. What numbers? What the answer sheet gave?
5.
Just 5?
I made sure and jotted down, and I put a question mark to it.
You mean for number 77?
Yes, sir.
I'm gonna look for it now. Two. 2.2, number 77. Look at that again. In question 60, exercise, find the car. Oh gosh. Sorry, I didn't look at the instruction. The instruction says in exercises 67 to 80, find the cardinal number for each set. So they didn't want you to list the members. They want you to give the cardinal number. So the cardinal number is the amount of members in the set. So it would be 2, 3, 4, 5, 6. So the number of members in that set is actually 5.
Okay. All
You
right,
follow
then. So I
me?
didn't read it. Yes, I didn't read the instructions properly then.
Yeah,
I was thinking that we had to, the only number we had to list was X would have been equal to or less than 2 and greater than 2, but less than 7.
right. So if they didn't ask for the cardinal number, if they asked you to list the members, then you would put 2, 3, 4, 5, 6. But the actual instruction says give the cardinal number for each set, which is the cardinal number means the amount of members in the set. So it's 2, 3, 4, 5, 6. And when you count that, that's 5 members. So the answer is 5. Okay, and then you said number 44. What?
Number
Oh,
49 in the last set.
okay, 49. Let me see. That's 2.2, number 49. Mm, Okay, 49. Okay, so that one instruction says in exercise 41 to 54, determine whether each statement is true or false. If the statement is false, explain why. So 49, it says 5. Okay, so that one is the one that says the set containing 5 is a member of the set containing the set 5, comma, and the set 9. That's the one you're referring to?
Yes, sir.
Yeah, so the answer is true because you see the the 5 is in brackets. So that is actually a set containing the element 5. And then is a member of, and then you see open brackets and then open brackets again. So within that set, you have 2 sets. One set have 5 in it and one set have 9 in it. So that set has 2 elements and each element is a set. So it means then, since it's listed like that, that means 5, that the set 5 is a member of that set containing the set 5 and the set 9. What is your query on that one?
I just didn't understand like how it would have had the open bracket and then had 5 in a set, close bracket, open
Okay.
bracket 9.
Okay,
That
so
confused me a bit.
yeah, so what is that? That's a set within a set. So that's actually 2 sets within that set. And one of those sets is the set containing 5. And so since the set at the front is also a set containing 5, then it's true that that is in that set. Okay?
Okay, thank you.
Yeah. Anybody else?
Question number 25 and 49 for exercise 2.2 on page 62.
Okay, which question you said again?
25 and 49.
Okay, 25. Well, 49 is the one we just did.
We had another 49 on the first section.
Oh, you said page 62?
Yeah, page 62.
Yeah, we did 49. That's the one with the set 5 is a member of. Is that the one?
Let me see. Sorry, 48, not 49.
Well, no, 48 wasn't one. No, I didn't give you 48.
No?
No, only all of the questions I give you are odd numbered questions. I copied the whole thing, but only the ones that are listed at the top, you're supposed to do.
Okay.
Yeah. So is there 25?
5, yeah.
Okay, so the instructions for that one, that's 2.2, as I said, number 25. So it's asking you in exercise 19 to 40, determine whether the subset or the proper subset or both, okay, neither can be placed. So number 25, if the set of all X or the X is a man and the set of all X or X is a person. So a man is a subset of persons, yes. And a man is also a proper subset of persons. So both symbols would apply because definitely man is a subset of persons and the set of men cannot be equal to the set of persons. So therefore, it would also be a proper subset. A proper subset is one in which the two sets cannot be equal. Okay, so because women would be included in persons, so in the set of persons would be a larger set than the set of men. So both symbols would apply. Man is a subset and it's also a proper subset.
Okay.
Okay? All right, so just remember the proper subset cannot be equal to the set that you're looking at. Okay, so, all right, so we're going to move on now to look at today. We are looking at section 2.3, 2.4. So I see 3 of your colleagues absent. I mean, I shouldn't be speaking to you about this, but if you know them, you need to let them know. In fact, I'm going to have to call the BIFS office to inform them because we really cannot afford to miss classes. There's too much to cover. And so if you really want to do well and pass the course, you need to attend classes because you're going to miss out. But for today, we are looking at section 2.3, 2.4. And so the focus is going to be on Venn diagrams. The short video at the beginning sort of touched on it. And here we are seeing that we use the Venn diagrams as a way to represent relationships between sets. All right, so you'll see on this diagram that's on the page displayed before you that we have a rectangle that represents what we refer to as a universal set. And a universal set would be will contain all the members within the set under discussion. And then sets within the universal set are represented usually using circles. We name the universal set, the symbol is U, and the sets within the universal set, we use capital letters to represent them. In this case, that the set there is called A. And you see within that rectangle, you see also A with a little symbol there. We're going to be looking at that a little later. It's referred to as the complement of A. So it would be the members in the universal set that are not in A. So the blue section would be the members outside of A or the region outside of A. So of course, this was named after the person who kind of, discovered it or used these diagrams to show relationships between sets. His name is John Venn, and he lived somewhere between 1843 and 1923. So we're going to start off by looking at a basic example here. Determining sets from a Venn diagram. So you have a Venn diagram here, universal set, and you're asked to determine each of the following. The first is the universal set. So the universal set would be everything within the rectangle. So in this case, it would be the little square, the triangle, the dollar sign, the letter M, and 5. And then the next, they ask you to list the members of A. So the members of set A would be the square and the rectangle and the triangle. And then the third, they ask you to list the set of elements in U that are not in A. And in this case, it will be the dollar sign, M, and 5. Those are the elements that are not in A. They're in the universal set, but they're not in A. So we're going to just look at a quick example here. I'm going to ask you to do this one. So you have a diagram, 2.5, universal set with the set A, and you're asked to list first the universal set, secondly, the members of A, and then C, the set of elements in U that are not in A. I'll give you a minute to do that, and then I'll call on you to tell me what you have. Okay, so Ms. Pratt, what do you have for the first one?
I have 1, 5, 7, 6, and 9.
Okay, thank you. 1, 5, 7, 6, and 9. Thank you. Ms. Fernanda, what you have for B?
1, 5, and 6.
Okay, Miss La Rochelle. Oh, Miss Nairn, what do you have for C?
7 and 9.
7 and 9. Very good. Okay, thank you. So that's basic sets. And so in that set with only one, that universe set with only one set, we have 3 regions. Well, 2 regions really. The universal set would contain everything, the set within the universal set, and then the set outside the universal set. Not outside, sorry, the set outside the set A. Okay. All right, so now we just looked at where we have one set within the universal set, but oftentimes we can have more than one. So here we are looking at cases where we have 2. So the disjoint set would be the first one. So disjoint sets here, when the sets are disjoint, it's because they do not have anything in common. So we have the universal set, and in this case, we have set A and set B. And set A and B do not have anything in common. So they are referred to as disjoint sets, and they are drawn within the universal set as 2 separate circles. Now, there will be times when we may have 2 sets which are equal within the universal set. And so in cases like that, the two circles more or less are on top of each other. Okay, so in this case, we have A equal B. Now, when we have a proper subset, we have what is shown here in this other diagram. All of the elements of one set are within the other. So that's a proper subset. So A is a proper subset of B. So there might be elements, there will be elements in B that's not in A, but everything in A is in B. Everything in A is in B, but not everything in B is in A. So therefore, A is a proper subset of B. And that's like the question you asked just now about man and person. Every man is a subset of the set of persons, but not every person is a man. There are some persons who are not men. So therefore, men or a man would be a proper subset of persons. Okay? These two sets are not equal. When two sets are equal, then we'll see this type of representation here, and it would be a subset, but not a proper subset. And then the fourth one is cases where we have sets with common elements. So we have what is called overlapping sets. Okay, and the common members would be where the two sets overlap. Okay, so once we have at least one member belonging to both sets, if you represent it using a Venn diagram, then we would have the sets shown in this fashion, overlapping. All right, so we have a diagram here. And this, by the way, that's page 66 of your book. So if you're using the textbook. So it says determining sets from a Venn diagram. So you're asked, in this case, to list the members of the universal set. Now here you will see 1, 2, 3. Those are Roman numerals, and another Roman numeral right here, 4. Those are just showing you regions. So within this diagram, we have 4 regions. The first region is A only. The second region, these persons belong to A and B. The third region, these persons belong to B only. And the fourth region, these people are not part of A and they're not part of B. So they're outside of A and B. So 4 regions. So these are not part of the set, they're just identifying the region. So the members of the sets are A, B, C, D, E, F, G. Well, the members within the universal set are A, B, C, D, E, F, G. So these Roman numerals are just identifying the region. So the first thing they ask you for is the universal set. And so in the universal set, A, B, C, D, E, F, G. In set B, we have D and E. C asks for the set of elements in A, but not in B. So A, they're in A, but not in B. So you'll see just A, B, C. We didn't list, even though D is in A, it's also in B, so we can't list it for this case. D asks you for the set of elements in the universal set that are not in B. So B has D and E, so we're gonna have to list everything else except D and E. So that would be A, B, C, F, and G. And then the last one asks you for the set of elements in both A and B. Okay, in both A and B would be D. D belongs to both A and B. And so those are different regions that we can identify in that Venn diagram. So I'm going to ask you to look at this next one. All right, so you have the Venn diagram 2.11. You have the 4 regions there, region 1, 2, 3, and 4. And you have universal set A, B, C, D, E, F, G. and you're asked now to identify some areas. So I want you to look at that and give your answers. Okay, Ms. La Rochelle, what is in A? Ms. La Rochelle?
A, B, C, and 1 I. Whatever the top one on top of A stands for.
Say that again.
A, B, C, and 1.
No. Remember I said to you, you talking this year?
1.
No, that's the region. So that's not a member of the set. This 1, this 2, this 3, and this 4. When we're doing sets, we use those to identify the regions of the set. They are not members of the set.
Okay, just A, B, and C.
Okay, now that's set A. You're missing something from A. I didn't say A only, I said A. What's inside of the circle A?
A, B, C, and D.
Right. A, B, C, and D. Okay. All right, Miss 1, 2, 3, 4. Miss Pratt, what's the answer for B, part B?
The set of elements in B, but not in A.
Mhm.
So we have E.
Okay, just E.
Yes.
Right. That's correct. Thank you. Miss Fernanda, C.
F and G.
Say that again.
F and G.
Okay, what does that say? That said a set of elements in U that are not in A.
E, F, and G.
E, F, and J. Right. Thank you.
Oh, yes, sorry.
Mhm. Okay, Miss Nairn, what you have for D?
F and G.
F and G, the set of elements in U that are not in A or B, F and G. Correct. All right. So those are the different regions within overlapping sets. All right. Okay. So who is this now? Pratt?
Glossy, and they like have like a
Pratt?
reddish tone to
Miss
it. Like
Pratt?
they ain't red, but
Miss Pratt, could you mute?
sorry, I'm sorry.
Okay. All right. So moving on now to look at the complement of a set. The complement of a set, and you see the symbol, A with the little accent there, is a set of all elements, a universal set that are not in A. Okay? And you'll see the set building notation for it. The set building notation is right here. So A with the little accent, A complement, or the complement of A, is a set of all X such that X is a member of the universal set and X is not a member of A. So in this diagram, A complement would be this blue region. Everything outside of A is A complement. That's the blue shaded area. Okay, and so that's one terminology we're looking at today. So let's look at this diagram. It says finding a set's complement. So the universal set here is 1 through 9, and A is 1, 3, 4, and 7. And so if we're looking for the complement of A, then of course, it would be all the members in the universal set that are not in A. And so you would see in this case, it would be just these numbers here, 2, 5, 6, 8, and 9. That's the complement of A. So let's look at this one. The universal set is A, B, C, D, E. A is equal to A and D. What is A complement? Ms. La Rochelle, what you have for that?
A, B, C, D, and E.
Say that again. I didn't hear you.
Not a complement would be B, C, and E.
B, C, and E. Okay. B, C, and E. Thank you. All right. So everything outside of A would be the complement of A. In this case, it would be C. So we didn't use a diagram, but just looking at what's in A has A and D. So you cannot include A and D in that. You want all the other elements except A and D, which in this case would be B, C, and E. Thank you. Okay. So now in the little short video before the class, you would have seen some explanation as to the intersection and union of sets. The intersection of sets A and B, the symbol is written as you see here, A intersect B. And so A intersect B would be the members that are in the overlap. Okay. And if we use set builder notation, as you see here, A intersect B is equal to the set of all X such that X is a member of A and X is a member of B. So in order for it to be in the intersection, it have to belong to the both sets. So it have to be in A and also in B. Okay. The union is the set of all elements that are in A or B or in both. And so you will see the set builder notation for union. And of course, the symbol is the reverse of what you see for intersection. It's like a U. And so A union B is equal to set of all X such that X is a member of A or X is a member of B. So key word here, or. So it's a member of A or a member of B. In the intersection, we use the word and. It's a member of A and a member of B. It belongs to A as well as B. Whereas this one, it could be in A or B for the union. And then there are some important points to note. For any set A, the intersection of A and the empty set, you're looking for what's common. Both of them have the empty set. So A intersect B, sorry, A intersect the empty set is the empty set. A union the empty set is A. So any set union with the empty set is the set itself. Any set that you intersect with the empty set is the empty set. So those are two key things to note. So let's look at an example, and then you're going to try some. So this one, it says find the intersection of two sets. So you have, in this case, 7, 8, 9, 10, 11, 6, 8, 10, 12. You're looking for intersection, so it's what's common to both. Oops, sorry. So in this case, it's 8 and 10. In the next case, there's nothing in common, so we put the empty set. And of course, you could have written it with just the curly brackets without anything in it. And then the next one asks for the intersection of 1, 3, 5, 7, 9, and the empty set. And of course, that would be the empty set because the empty set is common to all sets. Every set is has the empty set as a subset. Okay, and so those are the answers for those intersections. Let's try a few. Just to check if you understand. So we have, okay, Miss Pratt, give me the answer for A, please.
Hi, the answer for A is 7 and 10.
Thank you. Okay, Miss Fernanda, give me the answer for B.
Empty set.
Okay. Miss Nan, give me the answer for C.
Empty set.
Okay, thank you. Nan and LaRochelle. Okay. LaRochelle. Okay, thank you. All right. So now the union, some examples here. We combining the two sets. So in the first one, you are told that you have a set 7, 8, 9, 10, 11 to form the union of that with 6, 8, 10, and 12. Okay, so when you combine the two, that's what you get. If something appears twice, like 10, for example, you don't have to write it twice. 8 appears in both, you don't have to write it twice. Okay, so you just combine the two, and whatever is appears multiple times, you need to write it only once. In the next one, you form the union of those two. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. You don't have to put it in order, but it's encouraged that you do so. And then the last one, 1, 3, 5, 7, 9, union with empty set gives you back the 1, 3, 5, 7, 9. All right. So I'm going to go to Miss LaRochelle now. Tell me, what is the union of for set for A? Miss LaRochelle, are you with us?
Yes, the union is 1, 3, 5, 6, 7, 10, 11.
Okay, thank you. All right, so that's Miss LaRochelle. Back to Miss Pratt. What you have for B?
The union for B,
Mm-hmm.
1, 2, 3, 4, 5, 6, 7.
Thank you. And then Miss Fernanda for C.
1, 2, 3.
1, 2, 3. Thank you, Fernanda. Okay. All right. Okay. Now we are moving on to look at what they refer to as set operations. So sometimes we have to do operations with sets. And so the main rule that they have here is that you always perform operations inside brackets or parentheses first. And we have already looked at union, intersection, and complement. And I think basically the operations will involve a combination of either union, intersection, complement. Okay, so in this first one, A, you are asked for A union B, the complement of that. So you're given a universal set, which is 1 straight through to 10. A is 1, 3, 7, and 9. B is 3, 7, 8, and 10. They didn't give you a diagram, but you can just use the information there to help answer that question. So because you have brackets, they want you to do, they suggest that you do the brackets first. So the way we would start this is we would say A union B. A union B is within the brackets. So A union B would be 1, 3, 7, 8, 9, 10. So you combine the two to get one set. And now that you know what A union B is, now you should be able to find the complement, because the complement of that would be everything in the universal set that's not in A union B. So if you were to go to the universal set and cross out 1, 3, in fact, I could do that. You could cross out 1, 3, 7, 8, 9, 10, then you would be left with 2, 4, 5, 6. Okay, so the solution for that then, A union B, the complement of that would be 2, 4, 5, and 6. Any questions with that? Yes, we're all straight? Okay. So let's look at the next one. The next one says A complement intersect B complement. This one doesn't have any brackets, so we don't have to do any brackets first. We'll just tackle each one as they appear. So A complement would be everything outside of A. So that's the first thing you would do. So A has 1, 3, 7, and 9. So you look in the universal set and you write down all the members except 1, 3, 7, and 9. So that gives us 2, 4, 5, 6, 8, and 10. So we know what A complement is. So the next thing we're going to do is tackle B complement. So we know that B is 3, 7, 8, and 10. So B complement would be everything except the 3, 7, 8, and 10. So you look in the universal set, you write down everything except 3, 7, 8, and 10. And so you get 1, 2, 4, 5, 6, and 9. And so the intersection of those two now would be what's common to A complement and B complement. So you see you have 2 in both of them, 4, 5, 6. Okay, so the solution, the final solution then for that, A complement intersect B complement is 2, 4, 5, and 6. Okay. All right, if there are no questions, I'm going to look at a checkpoint and see how we make it with those. So we have, make it a little larger here. Okay, so we have universal set, in this case is A, B, C, D, E. Set A is equal to B, C. Set B is equal to B, C, E. And you're asked to find each of the following. A, the complement of A union B, and then A complement intersect B complement. So I give you a minute or so to work on those, and then I'm going to call on persons to answer. Miss Nairn, you'll do the first one, and Miss LaRochelle, you do the second one. But I want everybody to do it. But I'm going to ask Miss Nairn to give her answer for the first one, and Miss LaRochelle for the second one. Hello, is this the BFS office? Is Miss, yeah, is Miss Dean? Yeah, I only have 4 students. I don't know if they didn't get the link or what it is, but I'm teaching the 4 persons that's here. I don't see Chris McKem. I don't see Joel Pickstock. And I don't see Shantia Simon. Shantia didn't attend the first class, and now she's not in the second class. Krishna was in the first class, and Joel Pickstock was in the first class. Mm-hmm. Mm-hmm. Okay. And you see, when they miss class, is a lot that they miss, and you know, trying to catch up afterwards is going to be difficult. Mhm. Okay. All right then. Okay. Okay. So Miss Nairn,
Okay,
6A. Mhm.
A and D.
Okay. Very good. Thank you. Anybody want an explanation on that, or you all got the same thing? I guess we all
Yeah.
got it. Oh, okay, so we got that. Okay. Miss La Rochelle, what you have for B?
A and D.
A and D? Okay. The same thing. Yep, yep, okay. All right, thank you. Okay. Okay. All right, now earlier I mentioned to you about these Roman numerals. When you see them in the sets, for the most part, they're just telling you region. They're not members of the set. So in this case, in this diagram at the top, you have 4 regions. Region 1, region 2, region 3, region 4. And so in the table, they are just explaining to you which regions are formed by these different set operations that you see. So in A, we are looking at A union B. So it's a set of elements in A or B or both. So of course that would be regions 1, 2, and 3. So anytime you ask for the union of 2 sets using a Venn diagram, if you can picture those 3 regions, you list all the members or the elements in those 3 regions, and that would give you the union of A and B, if the sets are called A and B. In the second line, it's A union B, the complement of A union B. So we know that A union B would be region 1, 2, 3. So if you're looking for the complement of it, it would be everything outside of A union B. So in this case, that's region 4. So whatever is in region 4 would be outside of A union B. In line C, A intersect B. So it's a set of elements in both A and B. Okay, so the elements in A and B would be in region 2. So whatever is inside of region 2 in the Venn diagram would represent A intersect B. Of course, the complement of that, which is what is in line D, would be everything outside of that intersection. So it would be everything except region 2. So region 1, region 3, region 4 would be A intersect B, the complement of that. Now E and F is a little different here. In this one, it's asking you for the complement of A intersect B. So it's everything outside of A, what's common to everything outside of A as well as inside of B. So it says set of elements that are not in A and are in B. So that's region 3. So these are not in A, but they are in B. So what's common to B and the elements that are not in A? So that would be region 3. And of course, the next one says A, in this case, is the union B complement. So you're going to look at what's in A, and you're going to combine that with what's outside of B. Okay, so inside of A, you have region 1 and 2, and the union with B complement outside of B would be region 4. So in this case, it would be region 1, 2, and 4. So I think this chart should be somewhere around page 70 of your book, and identifying the different regions when you have two overlapping sets. Okay, so using that information, we're going to go through these 1, 2, 3, 4, 5, 6 different questions here. So let's look at the first one. The first one asks you for A intersect B. Okay, Ms. Pratt, which region would be A intersect B?
2.
Region 2. Okay, so and what members in region 2?
5.
5. Thank you, Ms. Pratt. Okay. Ms. Fernanda, this one is asking us for A intersect B, the complement of that. So that's basically saying what is outside of A intersect B. What regions are you looking at there?
Okay, so what's outside of A and B? I mean, intersect B.
Mm-hmm.
That would be 1, 2, 3, 7, 11, 13, 17, and 19.
Okay, now, remember now, you see this here? That's just the Roman
Sorry,
number.
sorry. Yeah, okay,
Yeah.
2, 3,
Mm-hmm.
2, 3, 7, 11, 13, 17, and 19.
Okay, thank you. Right. Okay, that was Miss, who was that again? Miss Fernanda.
Yeah.
Okay, Miss Nairn, what do you say to A union B?
That will be the regions 1, 2, and 3.
Okay, and so what elements in that?
So it'll be 2, 3, 5, 7, 11, and 13.
Okay, thank you. Okay. Okay, so that was that. So we're going to Miss La Rochelle. So let's La Rochelle, they're asking you here now for A union B, the complement of that.
That'll be region 4, 17, and 19.
Thank you. Right. Okay. All right. So we go back to Miss Pratt. Now, this one says they want A complement union B. So
Okay, so
everything.
the complement is everything outside of A.
Mm-hmm.
So the union, everything outside of A would be 2 and 3 and 5, 4, sorry. And then you want the elements?
Okay. Which one are we looking at again? E, right? Yeah, we're
E.
looking at E. Yeah. So A complement union B. So the first thing you have to do, what is A complement? Tell me what's A complement first.
Everything outside of A.
Tell me what they are.
So everything outside of A
Mm-hmm.
would be 2, 3, and 4.
No. Two is not two. Two is in A. We want A complement. So we want everything outside of A. What's outside of A?
So that's 3 and 4.
Are we looking at the same thing?
Because
You are
I'm looking at the same thing. Because
okay.
we're talking about the region, correct?
Oh, sorry. I thought you were talking the numbers. Sorry about that. Yeah, I thought you were okay. Yeah, I thought you were referring to the numbers. Okay, outside of A, A complement in terms of region, what region you said again?
It would be 2, 3, and 4.
No, 2 is an A.
So
3
3
and
and 4.
right. So what are the elements in A complement then?
And then it'll be 7, 11, 13, 17, and 19.
Okay. So A complement would be 7, 11, 13, 17, and 19. So in some cases, it's good to write it down so it makes it a lot easier. And then B now is equal to what?
B is equal to the regions 1 and 4. That's the region. And the elements would be 2, 3, 17, and 19.
Say that again. B, we're looking for B?
The elements, complement of B would be
No,
the
it doesn't
region.
say, no, it doesn't say the complement of B. It's only the complement of A. We're just looking, it says B. This is just B.
Oh,
Mm-hmm.
and we're looking for the elements. So it'll be 5, 7, 11, and 13.
Right. Okay. So B, it would be 5, 7, 11, and 13. So now they want the union of those two. So if you write the union of that now, that should be A complement union B. So when you combine those two, what do you get?
2, 3, 5, 7.
2? No.
The
So
union.
look. What is A complement? You see, we have A complement. We already list out A complement as 7, 11, 13, 17, and 19. B is 5, 7, 11, and 13. So we're going to combine those two to make one big set. We're going to marry
Oh,
those two.
okay. So it will be, you say the union.
Mhm,
And that's what the
union.
set they have in common, right?
No, that's intersection. You're going to marry the two of them and bring them together and make one big family.
Okay, so 5, 7,
Mhm,
11,
mhm,
13,
mhm,
17, and 19.
mhm. Okay. So just think of union as a marriage where you bring everything. The lady bring her stuff, the man bring her stuff, bring it all together and make one. That's what the union is. Okay, so anytime you hear the word union, you're bringing two things together to make one big group. And that's what the union is in this case. So we already identify A complement up here, and we identify B right here. So we bring the two together, and that's the result. Okay. So now in the last one, in this case, Ms. Fernanda, they ask you for A intersect B complement.
Okay, would it be region 1 and 4? That's 2, 3, 5, 17, and 19.
Let's do it step by step. What's in A? Ms. Fernanda, what's in A? Hello?
Hello.
Yeah, Ms. Fernanda, yeah, what's in A?
So for A, we have 1, I keep on looking at that. 2, 3, and 5.
2, 3, and 5. And what's in, it says B complement. So we want B complement. What's in B complement?
B complement would be 2, 3, 17, and 19. Oh my
2,
God, sorry.
3, 17, and 19. Okay, B complement, 2, 3, 17, 19. So now our job now is to find A intersect B complement. So the intersection is different from the union. With the union, you're bringing everything together. With the intersection, you're looking to see what do they have in common. What do those two sets have in common? A and B complement.
So they have 2, 3, 2 and 3 in common.
Okay, that's it.
Yes.
All right. Okay. So that's it for that.
Mr. Allen, I don't follow that the last question.
Mm-hmm.
You were saying that A intersect B complement.
Mm-hmm.
So I'm keeping in mind that the complement is everything outside of set B.
Right.
So, okay, I answered my own question. I was just looking at the region 4. I was wondering why the numbers of 4, but the region 4 was not listed.
Yes,
I
this
see it.
there.
I see it.
Okay.
Thank you.
All right then. All right, so I'm gonna move on then. Okay. So in sets, it can be helpful for us to be precise in our language. Okay. They're helpful for us to organize and represent relationships between different groups. And so, two things we need to basically remember, not to confuse these two, and or often refers to the union, because once the thing falls in one or the other, okay, and then and means that they belong to both of the sets. They fall in the two categories or three categories as the case may be. Okay, so now cardinal number, if you remember from last class or where we were looking at one of those questions for the homework, a cardinal number is the number of members in a set. So sometimes we need to find cardinal numbers for intersection of sets or the union of sets. And so they have this notation here explaining how to find a cardinal number of the union of two finite sets. Basically, all the sets that we'll be looking at so far, well, for the most part, are finite. That means you can list the members. There is a number that you could use to represent the amount of members. So here it says N of A union B, which means the number of members in A union B is equal to the number of members in A plus the number of members in B minus the number of members in A intersect B. So let me go back to this one here. So what is the number of members of A in this set? How many members are in this set? A.
3.
3.
3. Number of members in set B.
4.
1, 2, 3, 4. Okay. So what this thing is saying is that the number of members in A union B is equal to the number of members in A, which is 3, plus the number of members in B, which is 4, minus the number of members in A union B. How many members are there in A union B? Sorry, not A union B, sorry, A intersect B. How many members
1.
are there? 1 minus 1. Okay. So 3 plus 4 is 7,
Yes.
minus 1 equals 6.
Six.
So if you check and see number of members in A union B, in fact, we have it here, C, when we did C, it was 2, 3, 5, 7, 11, and 13. How many members that would be if you count them?
5.
2,
2, 3, 5,
5,
11.
7, 11, and 13.
Oh, it's a 6.
6. All right. So instead of counting them, you could use this equation, add the number of members in A to the number of members in B, and subtract the number of members that are in the intersection. And so basically that's what this is saying. The number of members in A union B is equal to the number of members in A plus the number of members in B minus the number of members in A intersect B. And so that is useful for when we have certain type of questions to solve. Like in this example here, it says some of the results of the campus blood drive survey indicate that 490 students were willing to donate blood. 340 students were willing to help to serve breakfast, and 120 students were willing to do both. So we have a set here that's willing to donate blood, that's 490. We have a set here that's willing to serve breakfast, that's 340. And then we have these people here, 120, that fall in both groups. So the question is asked, how many students were willing to donate blood or serve breakfast? Now, what does this or refer to again? Union or intersection? Union, right. So basically what they're asking you is for the union of those two. So based on the formula that's given at the top here, we know the number of members in A. In this case, let's call this the people who let's say the people who are doing blood drive is set A, and the people who are, okay, hold on, where's this? Okay, so the people who want to donate blood is A, and the persons who want to serve breakfast is B. So A would be 490, B would be 340, and the people who fall in both A and B is your 120. So you would add these two together, subtract 120, and that will tell you how many persons are in the union of those two sets. So basically, how many persons were involved in either serving breakfast or donating blood. And so let's look at the working which the book have on, I think it's page 73, if you have the book. All right, so they break it down just like I was trying to explain here. So you have your Venn diagram. Okay, so section 1, you set A, blood donors. Section B, breakfast servers. And then section 3, the people who are blood donors and also serve breakfast. And then of course, the people outside didn't give blood or they didn't serve breakfast. But we have two sets identified. So if you want to find a number of members in A union B, you're going to have to add the number of members in A, which you are told is 490, plus the number of members in B, which we are told is 340, and the number of members in A intersect B, which is 120. So 830 minus 120 gives you 710. Okay, so 710 students or persons were involved, either giving blood or serving breakfast. Okay, any questions with that? No? All right, so I guess you could look at this one then. So let's see if we have the components that we need for this one. So it says, the admissions department at a college looked at the registration of 500 of its students and found the following results. 244 students were registered in a mathematics class. 230 students were registered in an English class. And 89 students were registered in a math class and an English class. How many students were registered in a math class or an English class? Okay, I give you a couple of minutes to look at that. Then I'll call on you to tell me what's your findings. Mr. Pickstock, I see you with us. Good morning, sir.
Good morning. Sorry about that. I do really apologize.
So, you had a problem with the link or something?
No, I was to church this morning, and I kind of got home a little late.
Okay. All right. You did the homework?
You want me to email it to you?
Yeah, take a picture and email it to me, please, so I could give you credit for it. Let me put your name there, Joel. Okay, so let me hear from Miss Nan.
Okay. So to get the answer, we had to first add the 244 students who are in math with the 230 students registered for English, which will give us 474. And then we subtract the 89 students from the 474 who are registered in both English and math, which will give us the 385.
Okay. Very good. So it says how many students were registered in a math class or an English class would be 385. Now you notice they say here that 500 students so how is that 500 helpful? What could we deduce with that 500? Because we only got 385. Anybody have any ideas?
Maybe the difference of the students aren't registered for math or English.
Very good, very good. Okay, so these additional persons, so if you subtract 385 from 500, I think you get 100 and what's that, 15, those persons did not take math and they did not take English. So they didn't take those two subjects at all. So they would be outside. So if I was to put a Venn diagram here, and I have here, it would be, what's this first subject they have here? Math and English. In the middle, we have 89 falling for both. 244 registered in a math class. And 230 were registered in English class. Okay. And so the remaining 115 would not fall in. Okay. So that's how we do that. And by the way, suppose I wanted to find out how many persons did only math. What number should go in here? How many persons did math? That was Miss Nella. Miss
So-
La Rochelle. Miss La Rochelle, how many persons did math? How many persons registered for math? According to the question.
329.
329? No, that's not what's there.
244 registered.
244. 244. But in here, we already have 89 in the middle. So if I want to fill out this section here, how much do I need to put here to make sure that math was 244?
155.
Let me see, 155. So 155 plus 89 would give you 244?
Yes.
Okay. And what about the English? How much do I need to put in this section here to make sure that English was 230?
141.
141. Okay. All right. So that 155 then represents the people who did math only. But if you want to find how many did math in total, you'd have to add the 155 plus the 89 to get that 244. And then the 141, what does that 141 represent?
English.
English only.
Only, right. They didn't do math, they only did English. But if I want to find how many did English in total, then I'd have to add the 141 to the 89 to get that 230. Okay, thank you. All right, so we're finished with 2.3. And so we're going to go to 2.4. Now, 2.4 basically is the similar concepts, but this time, instead of looking at 2 sets, we are moving to look at 3 sets, operations with 3 sets. Okay? And so we basically follow the same procedure, but it's just involved a little bit more because we're looking at multiple sets. So we are given an example here where you're given a universal set. You're given 3 different sets. Set A is 1, 2, 3, 4, 5. Set B is 1, 2, 3, 6, and 8. And set C is 2, 3, 4, 6, and 7. And so in this case now, they ask you to find A union B intersect C. Okay. And because you have multiple things going on here, I have these arrows showing you what you need to do in each case. So for finding A union B, they usually suggest you deal with the brackets first. So you would find first you would find B intersect C, then you would find the union of the two. In the next one, you have 2 sets of brackets. So whichever bracket comes first, you deal with. So here you would find, first you're going to find A union B, then you're going to find A union C, then you're going to find the intersection of A union C. Okay. And then in this third one, you have brackets. So within this bracket, though, you have C complement. So it's not just straight C, so it's best to do that first. So find the complement of C. It's the first step. Then after that, you find the union of B and C complement. Then you find the intersection of A and B union C complement. So it's similar to what we do with two sets, but it's just that it involves a few more steps because you're dealing with three different sets, subsets within the universal set. So I have those three examples. We're going to look at each of them. So the first one was 1A. So they ask you in 1A for A union B intersect C. So the first thing we said was we're going to find deal with the bracket first. B intersect C. So B intersect C. So you're looking at B and C and looking to see what's common. So B intersect C. They list out B 1, 2, 3, 6, 8. They list out C 2, 3, 4, 6, and 7. And then intersect what's common 2, 3, and 4. So that's the intersect C. That's common to both of them 2, 3, and 6. So once we get that, then we're going to find the union of that and A. So first we list out A. A is 1, 2, 3, 4, 5. We already worked out that B intersect C is 2, 3, and 6. So we put it here. And then now we're going to form the union of the two, which means you're going to combine the two to make one big set. So it's going to be 1, 2, 3, 4, 5, 6. Okay. And so that's how we'd solve something like that. So we go it step by step. Deal with the brackets first. And if you have operations within the bracket, then you deal with the operation within the bracket. Then deal with the operation within the bracket. Then you combine whatever other set is in the bracket, and then you expand to those that are not in brackets. That's 1A. Let's look at 1B. So 1B, you have two sets of brackets, A union B, A union C. So this is A and B. So what they did, A union B, they list the members of A, which is 1, 2, 3, 4, 5. They list the members of B, which is 1, 2, 3, 6, and 8. And then the union would be combining the two to make one big set, 1, 2, 3, 4, 5, 6, and 8. All right. Now, the next bracket is A union C. So A is 1, 2, 3, 4, 5. C is 2, 3, 4, 6, and 7. And the union of those two is 1, 2, 3, 4, 5, 6, 7. And then the final thing we're going to do, we found A union C, we found A union, we found A union B, we found A union C. Now we're going to look for the intersection of those two. So A union B intersect A union C would be the answer you got for A union B, which is right here. Intersect, the answer you got for A union C. And you look for what's common to them. And the common elements are 1, 2, 3, 4, 5, 6. So the answer for that one would be 1, 2, 3, 4, 5, 6. Okay. And let's look at the third one, 1C. So in 1C, you're told to do A intersect B union C complement. So you have the brackets here, so you're going to deal with the brackets first. But because you have this complement in the bracket, you deal with that complement first, then you deal with the union of those two. So C complement, this is C, 2, 3, 4, 6, and 7. So you're going to look in the universal set and everything that's not 2, 3, 4, 6, and 7, you're going to write them out. So C complement, in this case, would be 1, 5, 8, and 9. Okay. And then you're going to say B union C complement. So B is 1, 2, 3, 6, and 8. And C complement, we got the answer up here, 1, 5, 8, and 9. the union of them would be right here. 1, 2, 3, 4, 5, 6, 8, 9. So now A intersect B union C complement would be, you know what A is, 1, 2, 3, 4, 5. You know what B union C complement is. You got the answer up here. You list it here, and then you look to see what's common between two of them, since we're looking for intersection. That would be 1, 2, 3, and 5. And so that's your answer. So it's kind of easy in a sense, but it's just that it's a little more tedious because you have more sets to look at. And so you have to, so you have to be careful. And it's always best to do it step by step, write down each set so that you could do the comparison. And then you would be able to derive the final answer if you go step by step. So let's look at this this one here. Set checkpoint 1. So we have a universal set of A, B, C, D, E, F. Set A is equal to A, B, C, D. Set B is equal to A, B, D, F. And set C is equal to B, C, and F. And they ask you to find the following sets. So the first one is A union B intersects C. So let me see who is next on my list. Miss La Rochelle. Let's go through this one. Tell me how you're going to start.
I'll start with the brackets.
Okay.
C.
Okay. All right. So B intersects C. So B is equal to?
B is equal to A and B.
No. I want you to list all the members in B.
Okay. A, B, D, and F.
A, B, D, and F. Yeah. And C is equal to?
B, C, F.
B, C, and F. Okay. So now what is B intersect C?
That'll be B and F.
Okay, B and F. Okay, B and F. Okay. So now, so you know what B intersects C is. So now you're going to say A union B intersects C. So you know A is, what is A?
A, B, C, and D.
Okay, so that's A, B, C, and D. And you want to union that with B intersects C. What did we work that out to be again?
B and F.
Okay, that's B and F. So the answer would be then?
A, B, C, D, and F.
Okay, A, B, C, D, and F. Thank you very much. Okay, so that's A. Mr. Pickstock, it's your time. Are you there? Oh, Mr. Pickstock left. Oh, boy. Okay, mark him absent. Okay. Disappeared. Okay, so I guess I have to go back to one of the ladies. Miss Pratt.
Hi.
Okay. What we're gonna do with B? Let me hear how you're gonna tackle that one.
So both are brackets.
Mm-hmm.
So we're gonna list the unions of A and B
Okay, so we're gonna have
and C.
A equal, so you're gonna, since both are brackets, just start with the first bracket.
So A, B, C, D.
Okay, A equals A, B, C, and D,
And then B equals A, B, D, and F.
A, B, D, and F,
And C equals B,
Okay,
C, F.
well, no, we don't need to go to C yet. Just do A
Okay.
union B now. A union B is equal to what?
A, B, D.
Union.
A,
This,
B,
this is a marriage.
C, A, B, C, D, and F.
A, B, C, D, A, B, C, D, F. Right. Now, so we finished the first bracket. Let's go to the next bracket. So it's going to be A equals,
So
what's
A
A?
equals A, B, C, D.
And C equals
And C equals B, C, F.
B, C, F. And now,
And we're doing this is a subset or not union. It didn't ask for, oh yeah, sorry, union.
A union C,
So it'll
equal
be A, B, C, D, and F.
A, B, C, D, and F. Okay. All right. So now, so we have A union B and we have A union C. So now we're going to do the full thing now. So it's going to be A union B brackets intersect A union C would be equal to, the answer we got for A union B was A, B,
B, C, D, F.
C, and F. And we're going to, that's going to be the intersection with the answer for A union C, which is
A, B, C, D, and F.
okay. So what's common to both?
All.
Okay. All right. All right. So A, B, C, D, and F. All right. A, B, C, D, and F. Okay. A, B, C, D, and F. Thank you. All right. So that was Miss Pratt. All right, Miss Fernanda, the last one.
Okay, so we start with the brackets.
Okay.
That's B. B is A, B.
Okay. B equals, you said
A, B, D, F.
A, B, D, F.
And then it says the union C complement. So that would be,
We need to find C complement first before we do anything else. In
so
fact,
C complement would be,
I would have preferred to, if you start with C complement before B, but you could do C complement after. But what's C complement?
so C complement would be, let me say C. So that would be A, D, E, F.
All right, so let me see what C is again. B,
No,
C,
sorry,
F.
not F. A, B,
Yeah.
C. No, A, Jesus, I get confused, sorry. A,
All right. All you have to do, what
D,
is C? C is B, C, and F. Look in the universal set and
yeah,
cross out B, C, and F.
F.
Once you cross those out, what's left would be so what's left?
That's A, D, and E.
A, D, and E. So we cross out this F. All right. So B is A, B, D, F, and C complement is A, D, E. So now we want B union C complement. So B union C complement would be equal to A, B,
E,
D, F. I'm trying to save space here. Union A, D, and E. So when you union those two, the answer is what?
when you union both of them, you will get A,
Okay.
B,
A,
D, and F.
B, A, B what?
D
D.
and F.
I see something else there.
E and F.
Okay, E and F. Okay. So that's the union of B and C complement. Now we need to find A intersect that. So A again is equal to
A is A, B, C, and D.
A, B, C, and D. Okay, so now you want the intersection of that. So A
A,
intersect B union C complement would be equal to A. We already know A is A, B, C, and D, and then intersect with B union C complement. What answer we got for that?
we have A, B,
A,
C.
B. This is the answer. Yeah?
We have A, B, C, D, E, and F.
Oh, you gave me the answer. I want you to tell me what is B union C complement.
Oh, I didn't write it down. B union C complement B.
You see, I have it circled right here. The answer we got. You see it?
Oh yes, I can't get all kind of numbers now. You're at the bottom?
Oh, you don't see where I have the circle?
No.
You can't see then. Oh. Can you see it? I have a dot, a big dot right here.
Okay, I see. A, B, D. Yeah, A, B, D, E, and F.
E and F. Okay. So now A is A, B, C, D intersect the A, B union C complement, which is A, B, D, E, and F. So what's common to both?
A, B, and D.
A, B, and D. Okay. So that is it. That's C. Thank you. All right, so it's just step by step. Identify the various regions and then do the combinations, the operations in order. Okay, so that's checkpoint 1. Now, the same way we have, when we're looking at two overlapping sets, we usually identify 4 distinct regions. When it comes to 3 overlapping sets, we end up with about, I think it's 8 distinct regions. So, and then in the same way we use the Roman numerals, we do the same thing here. So this is region 1, 2, 3, 4, 5, 6, 7, 8. All right, so each region, the region numbers are not part of the set. They're just identifying the region. Okay, and so you see on the right-hand side a description of what each of those regions are in words and also in set language. Okay, so it's 5, region 5, the region shown in dark blue or the darkest blue there would be the A intersect B intersect C. So that region is common to all three. So that the people in, or the elements in region 5 fall in all three sets. In this case, there would be an A and B and C. In the case of region 2, 4, and 6, those are the areas that's shaded in the light blue. Okay, so region 2, it says this region represents elements in both set A and B that are not in C. So there is the intersection of A and B and the intersection of C complement. So they're in A and B, but not in C, which is the description right here. A and B, but not in C. So that's C complement. And then in region 4, you could follow the same pattern. Region 4, which is right here, they're in the intersection of A and C, but not in B. So that's intersect B complement. And of course, region 6, following that same pattern, they fall in B and C. So B intersects C, but they're not in A. So it's B intersects C, intersect A complement. So I want you to look at the pattern. So region 2, you fall in A and B, but you're not in C. So not C is the complement of C. So you're using intersection straight through, A intersect B, intersect C complement. The next region 4, A intersects C, intersect B complement. So they're in A and C, but not in B. And not in B is the complement of B. And then region 6 is B intersects C, but not in A. All right, so the last one now is the areas where it's not shaded at all. Okay, so there's those areas in white. So the first area in white is region 1. It says this region represents elements in set A that are neither in set B nor C. Okay, so you look at how it's noted. You're in A, intersect the complement of B, intersect the complement of C. So A intersect the complement of B, intersect the complement of C. That means you're in A, but you're neither in B nor C. So you're only in A. And the same pattern follows for the rest. So region 3, B intersect A complement, intersect C complement means you're in B, but you're not in A or C. And the other region, region 7, you're in C, but you're neither in A nor B. So that's the designation there. And then the last one, region 8, is outside of all of those three. A intersect B, sorry, A complement, intersect B complement, intersect C complement. So it's outside of A, outside of B, outside of C. And I want you to notice that in all of these, they're using these single regions, we're using the intersection symbol in these single regions here. Intersection, okay? Intersect, all right? When you just identify a single region. Okay, of course, we can use union as well, but in this case, we are looking at just a single region. Suppose I ask you which region is for A intersect, sorry, not A intersect. Yeah, A intersect B. Which two regions fall in A intersect B? Anybody could answer that? Which two regions fall in A intersect B?
2
5.
2, region
And-
2,
and 5.
and 5. Okay, so, all right, 2 and 5 would be A intersect B. Which regions would represent C? We're talking
7.
all of C now. 7 is C only. 7 is C only. That means it is C, but it's not in A or B.
So
But I
that's
want
4, 5, 6, and 7.
4, 5, 6, and 7. So C contains 4, 5, 6, and 7. So if I want all of C, then it would be 4, 5, 6, and 7. But if I want only C, then that would be C intersect A intersect B. Sorry, C intersect A complement intersect B complement, which is C only. But if I want all of C, then I would have to list all those regions, 4, 5, 6, and 7. Okay. So these designations that you see here are only referring to one region. But in some cases, you may have to state multiple regions. All right, so let's look at this example. So you notice I highlighted the regions in yellow because they are not members. They're just used to identify the region. So we have some numbers in the set. And so we want to identify what numbers make up the set. So for set A, we know A, it consists of multiple regions. We don't want just A only. We want all of A.
You want us to give you the numbers, or are you calling on
Yeah.
people?
Yeah, give me the numbers for set A, yeah.
11, 3, 12, 5, 7, and 6.
Let me hear you. 11, you said 3, 5, 7, and 6,
And 12.
and 12. Okay, let's see. 3, okay, 1, 2, 3, 4, 5, 6. Okay, yeah. All right, so that would be equal to those. All right. All right, what about A union B? That was Miss LaRoche. Let me ask Mr. Mann. Yeah, okay, yes, sure. Yeah. Okay, Miss Pratt, tell me what's in A union B. Give me the numbers there.
11, 11, 3, 6, 12, 5, 7, 1, 2, 10, and 9.
Oh boy, I lose track of what you said. 11, 3, 6.
11, 3,
12.
6,
Mhm,
5, 7, 12. You missed out 7.
mhm. That's it?
1, 2, 10, and 9.
Okay. So that's A union B. All right, Miss Fernanda. What about B intersect C?
Okay, so B intersects C. So that would be 5, 7, 9, and 8.
8.
No, sorry, not 8. 5, 7, and
Mhm.
9.
Okay. That'd be 7 and 9. Okay. All right. Thank you.
Providing
All right. Miss Nairn, what about C complement?
C complement would be 11, 3, 1, sorry, 11, 3, 12,
Mhm,
1, 2, 10.
mhm. Okay. All right. That was Miss Nairn.
Yes.
Okay. And Miss La Rochelle, what about A intersect B intersect C?
That'll be 5, 7, and 12.
5, 7. So I didn't say 6 and 9.
So, 6 and 9 is only, okay, 9 is B intersect C and 6 is A intersect C. So that's not,
What about 12?
I said 12. Wait, just 5 and 7.
Thank you. Thank you. 5 and 7. That's it. Yeah. Okay. A intersect B intersect C is just 5 and 7. Thank you. All right. Oh, okay. All right. Okay, so these are the answers. Let me double check. Okay. Okay, yeah. Oh, we missed something for C complement. What we miss? Let's see. 11, 3, 12, 1, 2, 10. We missed 4. C complement. Where's the 4 in this? I don't see a 4. C complement. Anybody with the book, tell me which page this is on?
79.
72. Oh, sorry.
79.
Okay. Okay, yeah, I was looking to see. Oh, there's a 4. Okay. There is a 4 in the book, but my diagram doesn't have the 4. Okay. I see. Okay, so this PowerPoint that I have, some of it might be from the earlier edition. So they made 1 or 2 changes, which I didn't get. So your book has 4 on page 79. So that's why there's a 4 here. But this diagram doesn't have the 4. The 4 should be right here. Okay. Let's check the other one. 5, 7, 9, 11, 3, 12, 7, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so that's it. Yep. All right. Number 2, checkpoint 2. I think I'm gonna skip that one in the interest of time and move on. It would be sort of similar to what we just did. Okay, you know what? Look at E. A union B union C. Miss Pratt, tell me what you would do for that. What are they asking for there?
They're asking for A union B union C.
So
So
how would you?
that'll be all of A, which will be 11 and 3.
6, 5, 7, 12. Hold on. 11 and 3. Yeah, 6, 5, 7, 12. 1, 2, 10, and 9.
And one more. Remember, we have
3.
C in that too.
Oh, sorry, 8.
Okay, so everything in the those three sets combined. So instead of 2 people marrying, now we have 3 people marrying. So we're going to combine all 3 to make one big union in ABC. All right. Okay. So now we have sometimes to construct Venn diagrams based on information that we are given. So what they're saying to you, the first thing to do is identify the intersections and start with the innermost and work outward. So in this example, you're given the universal set A, B, C, D, E, F, G, H, I, J, K, L, and then you're given 3 sets within that, A, B, and C, and they want you to represent the information in the Venn diagram. So the first thing you need to do is identify the elements that belong to the innermost part, which would be right here. So that innermost part would have to be the elements that fall in A, B, and C. So what do you identify that falls in A, B, and C? Hmm? Which elements fall in A as well as B as well as C?
A is 1. No, sorry. G and H.
G, I don't see G in set C. I
H,
don't see
sorry. It's
H,
only
okay.
H. It's only
H
H.
fall in all 3. There's another one that fall in all 3.
E.
E. So E and H would fall in all 3. So E, I should have, okay. Anyway, E and H. So once you identify what's in all 3, then now we need to look at A and B. Let's look at A and B. What's in A that's also in B? Anybody? What's in A and also in B? B?
E, G,
E,
and H.
H.
E, G, and H. Okay, so we already have E and H, so we just need to put G then. Right? We already have E and H in the very middle, so we just need to put G to make sure that A intersect B have E, G, and H. And now, since we already clear up with A and B, then now we look at B and C. What's in B and also in C?
E. No.
B as well as C.
E and H.
E and H. All right, now we already have E and H in the very center, so we can't put anything else here then, because we already have E and H. E and H falls in B and C as well as A. So we already have E and H in the center. Now let's look at A and C. Is there anything that's common to A and C?
A and E and H.
A.
A, E, and H. So all we need to put here then in this
It's A.
section is what? A, because
A.
we already have E and H in here. All right, so now that we have put in the innermost parts. We did with the center first with E and H, then we have G here, then we have A. We don't have anything extra here. Now we need to look in A and see what else we need to fill in. Okay, because we already put in G, we already put in E, we already put in H. What else we put in? We already put in A. So what's left to put in A? That's in A only and not in the rest.
That's
D,
D,
I, and
I,
J.
and J.
Okay, it's D, I, and J. Those three are in A only. They don't belong to the rest of the sets. Anything in B that doesn't belong to the rest of the sets?
B, B is in
B,
ball.
B, okay. Something else I see.
G, no, we
We
have G
already have
already.
G.
We already have
Mhm.
G. L, L,
L, L, okay, right. And then look at C now. Is there anything in C only and nothing the rest?
C,
C, C, yeah, okay. Now, we have to check the universal set now and see if there's anything that we did not list at all in those three sets.
F,
F, okay, so F belongs outside because it doesn't fall in any of the three sets. Anything else? I think I see at least one more.
K,
Okay, okay, that's it. So that's how we complete the Venn diagram. We start with the innermost, look to see what's common in all three. Then we look for the ones common in two. Then we look for the ones that only fall in a particular set. And then we look to see if there's any that doesn't fall in any of the sets at all. All right, so I want you to do this one. Draw up a quick Venn diagram and see if you could fill in the spaces for that particular one. Okay. Right now, let me see. Okay, Ms. Pratt, what you have in the center?
I have 10.
Only 10?
That is for the 3 sets,
Yeah, only 10.
only 10.
Okay, thank you. 10. Thank you. Ms. Fernanda, what you have above 10? Right above here, anything?
No, I don't have anything.
Nothing there. Okay, that should be empty. Thank you.
Okay.
Ms. Nairn, what do you have to the left of the 10?
I have 3.
Okay, thank you. Ms. La Rochelle, what do you have to the right of the 10?
9.
Mm-hmm. Only 9?
And 4.
Okay, thank you. All right. So go back to Ms. Pratt. So what else do you have in A?
1 and 6.
1 and 6. Okay. Thank you, Ms. Pratt. Ms. Fernanda, what else you have in B?
7.
7. All right. Ms. Nairn, what else you have in C?
5 and 8.
5 and 8. And Miss La Rochelle, what you have outside of all of them? Miss La Rochelle, are you there?
Sorry, what was the question?
Yeah, what is there any member in the universal set that's not in those 3 sets?
Number 2.
2. Okay. All right. I must say y'all doing well. So far, so good. Very good. Thank you. Mhm. All right. So that would be it for that Venn diagram. So we have filled in the elements in all the spaces that, according to the figure, the numbers were given. All right. So now we're trying to round up this. So we have on page 81, they're making reference to proving equality of sets. And it says we can apply deductive reason using a Venn diagram to prove this statement is true for all sets A and B. If both sets represent the same region in this general diagram, then this proves that they are equal. So we have an example here. They ask you to prove that A intersect B complement is equal to A complement union B complement. Okay, so we have the diagram, and first they're going to begin with A intersect B complement. So we identify the regions. A is region 1 and region 2. So now we don't have any elements in here. We're just looking at the regions. B is region 2 and 3. A intersect B is region 2, and A intersect B complement is therefore everything outside of region 2, which would be region 1, 3, and 4. So we show now that A intersect B complement, the complement of that is regions 1, 3, and 4. So that's just a step-by-step process as to how we identify the region here. And so on the other side, we're going to do A complement union B complement. So here we are the complement of A intersect B, and now we're going to look at A complement union B complement. So we basically going to identify A complement, that's just everything outside of A, which in this case is region 3 and 4. B complement would be everything outside of B, which is region 1 and 4. So when we do the union of A complement and B complement, we'll have 1, 3, and 4 when we unite the two. Okay, so you will see then that this region 1, 3, and 4 is the same as this. The two are the same, they're equal. So basically what we have done is to prove that the complement of A union B is the same region as A complement union B complement. And so that's the process we go through to prove the equality of sets. So when we prove the equality of sets, we use the regions to show whether or not the regions are the same. If the two regions are the same when we're through, then we can say the two sets are equal, or the two, yeah, okay? So in this example, they're asking you to use the Venn diagram to solve this exercise. Which region represents A union B complement? So, Ms. Pratt, tell me how you're going to tackle this one. A union B complement. Which region would that be? How would you tackle it?
That would be the region that is not in B. And that would be 1.
Okay, look at it. I have brackets. A union B, the complement of that. Now, there are two ways you could tackle this. You could break it down, A, then B, then A union B, then A union B complement.
Okay, so A equals region 1 and 2.
Okay, 1 and 2.
And then B equals region 2 and 3. And then B complement.
No,
A
we don't have B complement here now. We have A union B.
A union B.
Mhm.
It'll be 1, 2, and 3.
1, 2, and 3. Now we have the complement now.
1 and 4.
A union B.
Complement, sorry.
So what is A union B? We know A union B is 1, 2, 3. So we want the complement of A union B.
It should be 4.
Just 4, right? So we want everything outside of that. Okay, so that's region 4. So that was Miss Pratt, right?
Yes.
Okay. Now, Miss Fernanda. So that was A union, the complement of A union B. Okay. See, this complement is outside the bracket, so it's applying to all of A union B. So you break it down, A, region B, then A union B, then the complement of A union B, which is region 4 only. Okay. Now, Ms. Fernanda, I want you to look at the next one, which is A complement intersect B complement. No brackets involved here. A complement intersect B complement. So we'll just go straight to A complement. So Ms. Fernanda, what's A complement?
So A complement is 3 and 4.
Region 3 and region 4. Okay. And then B complement is
1 and 4
okay, 1 and 4.
and 4.
Okay.
So the
So
answer will be 4.
so A complement intersect B complement would be region, what's common to them? Region 4.
Mhm.
Okay. All right. So this is asking us, based on parts A and B, what can you conclude?
Pardon?
Based on what we just did. This is the answer for part A, and this is the answer for part B. What can you conclude?
Basically, it's everything that's not inside the sets. It's outside
Hmm,
the set.
okay. But what can you say about A, the complement of A union B, and A complement intersect B complement?
They're equal.
Okay, that's basically what they wanted you to say. That A union B complement of it, the complement of A union B is the same as A complement intersect B complement. So the union of A, sorry, the complement of A union B is equal to A complement intersect B complement. They're the same. So this one is a union, but the union of the complement of the union is the same as A complement intersect B complement. And that's true for all sets. Okay. And so you will see here, page 82 of your book, they have this thing they refer to as De Morgan's laws, which we just proved. And let me see, this one we did was A union B, the complement of A union B. Okay, so the one we just did was this. And the one that we looked at in the example was this. So these are referred to as theorems or laws. And this person here probably was the first person who came up with it. And what the first one is saying is the complement of the intersection of two sets. All right, so intersection, the complement of the intersection of two sets is the union of the complements of those sets. The union of the complements of those sets. And the one we did just now, the complement of the union of two sets is the intersection of the complements of those sets. So here we have A intersect B complement is equal to A complement union B complement. And if you reverse it and you change from intersection to union, then basically you end up reversing this, changing that from union to intersection. So you see that once we reverse, we reverse on this side too. And that's true for all sets. All right. So you don't exactly have to memorize it, because if you are able to prove it, then you should be able to derive that on your own. It's referred to as De Morgan's law. You don't have to remember De Morgan's name, just understand how to prove that the two sets are equal. Okay, so basically with the three sets is the same process. So I'm not gonna go through this. You have, I'll send the slide to you so you can look at it. But the main thing is that you identify the various regions and you show that the regions concerned are equal. If they're equal, then you have proven equality. If they're not the same regions, then the sets are not equal. Okay. And so we'll skip that and we get on to this test. But before the test, I want to show you, I'm going to send this slide to this presentation to you. So your homework for section 2.3 is page 74 in your book. But if you just, depending on the slide, these are the questions you're going to do, not all the questions. You're going to do questions 1, 5, 9, 13, etc., up to 139. And the questions are right here. They start on slide 44 and they go to slide 45. Okay, so it's just 2 slides. The questions are right here. Okay, slides 44, slides 45. And then on slide 46, you have questions from page 83, section 2.4, and the questions are 1, 5, 9, 13, etc., to 65. And the questions are right here. So I have all the questions, but only the ones that you see listed, you need to do. Okay, so that's slides 46, 47, 48. So the questions for that part. For even the odd numbered questions, but you just look for the ones that you're asked to do, and the answer should be there. And then if you have any questions next class, you're not sure. But as soon as you do the homework, you could take a picture of it and send it to me. I'll usually respond either Friday night, Saturday morning to say received. I'll check for it Friday night to see if you did it, and I'll record your score, and then I will probably send you a sheet with your scores. I'll probably do that next week, give you your grade sheet so you could see where you stand so far. I would have the homework and this test that you're going to do today. Should have that ready. Now, I sent you an email asking you to print a sheet because I want you to answer the questions on that sheet that I asked you to print. And so what I'm going to do is to display the test in a minute. Before I do that though, any questions? We are clear on the homework? Yes, no? Yes,
Yes.
Okay, Miss Fernanda and Miss La Rochelle?
Yes.
Yes, okay, okay. All right, so let me go back to the test. Now, let me see, share screen now. And I think I want to stop recording. Let me see. Share. Record. Stop. We receive an email when the recording is ready. Okay.